So for 9.4, we're going to talk about the tangent ratio. And so the next couple of days, we're going to talk about trigonometry. And trigonometry is just comparing two of the three sides of a right triangle. So if I have a right triangle that looks like this, where I label this as A, and this as B, and this as C. Remember, C is always the 90-degree angle. Capital letters are the angles, and the lowercase letters are the side lengths. So if I wanted to say, if I'm focusing on angle A, well, let me just write it out. So if I say the tangent of A, that means I'm focusing on this angle here. The tangent is always the opposite side over what we call the adjacent. So on a triangle, if this is the measurement or the angle that I'm interested in, because this is tangent of A, first of all, the side across from the 90-degree angle is always going to be the hypotenuse. Okay? And then the side across from angle A will always be the opposite. And then the third side left over is what we call the adjacent. Okay? And let me make that a little more clear because it looks like it's running into the C. So this third side is what we call the adjacent. Okay? So tangent is going to be the measurement of, or the ratio of the opposite over the adjacent. Okay? So to write this out a little better, the tangent, or the ratio of these two sides, which is the opposite over the adjacent, I misspelled adjacent. This first thing in the morning thing is killing me. So the opposite then would be the line segment BC, or and then the adjacent would be AC. Okay, so all of our problems are going to be set up the same way today. So I'm going to find an angle, and then I'm going to focus on the opposite over the adjacent. Those are the ratios. Those are the values that we're interested in. Okay, so let's do example number 1. So for example number 1, we're given a right triangle that looks like this. And it's not quite drawn to scale, obviously. But this would be 18. This would be 82. And this is 80. And then my triangle is RST. And I'm asked to find the tangent of S. So this is my angle that I'm curious about, right? So remember that the tangent of any angle is going to be the opposite over the adjacent. So if this is my angle that I'm curious about the ratio, the opposite side is across from the angle itself. So in this particular case, it would be 80. Why? Because this is my angle S, and across from or opposite angle S is 80. This is the hypotenuse always. Why? Because it's across from the 90-degree angle. That doesn't mean a whole lot today, But when we do sine and cosine, that's kind of a big deal. So then the remaining side would be what we call the adjacent. So we've got 18 over 80. I have two even numbers, so I could probably reduce that down. So if I divide 80 by 2, that becomes 40. And then if I divide 18 by 2, it becomes 9. So that reduces down to 40 over 9. Okay? So then, let's say I want to know what the tangent of R is. Well, it's still going to be the opposite over the adjacent, but you'll see that that changes because we're focusing on a different angle. So if this is R, angle R, what is opposite of angle R? Well, the opposite of angle R is actually 18. Okay? And then the adjacent of R is going to be 80 because it touches the angle. And then that reduces down to 9 over 40. Okay? So we have whatever angle they give us, we're going to go and do the opposite over the adjacent. So for S, the opposite of S was 80, the adjacent was 18, which gave us 80 over 18. For the tangent of R, we're going to go opposite of R, 18, over the adjacent, which is 80. 18 over 80 reduces down to 9 over 40. Okay? And that's basically what we're doing. Let's move on to the next problem. For example number 2, I've got an angle like this, where I'm told this angle is 32 degrees, this is X, and this is 11. Okay, so again, I have an angle here. This is a right triangle. So then across from the right triangle is the hypotenuse. So this is my 90-degree angle. Across from it is the hypotenuse. This is the angle that they've given me. So opposite that is over here. This is the opposite. And then the remaining side is what we call the adjacent. Now, adjacent really means that it's touching. In other words, this side is touching the actual angle, 32. Okay? So then what we want to do is we are going to go through and figure out what X is by saying tangent of the angle 32 should equal the opposite over the adjacent. Okay? Alright, so what does that mean? The tangent of 32 is equal to the opposite, which we know is 11, over the adjacent, which is X. Now this is an interesting thing because we need to solve for X. The tangent of 32 is actually a number. We could plug that in a calculator and get a numerical value for it. So I have a number, and this. So what I'm going to do is I just want to show you that. Now on your calculator, you need to make sure that you're in degree mode. On these cheapy calculators, it'll say right here DEG. That means I'm in degree mode. Okay? So if I hit tangent of 32 degrees, that gives me a number. Okay? Now I'm going to write that out pretty far. So tangent of 32 is actually 0.624869, and that's equal to 11 over X. In other words, tangent of 32 degrees, if I plug that in the calculator, should equal the 0.624863, and so on. Okay? And all that is comparing this measure of angle 32. There should be a common ratio, right? So if I have a similar triangle that's bigger, the ratio from here to here will be proportional. Okay? So anyways, 32, tangent of 32 has a numerical value of 0.64869, and that's equal to 11 over x. We want to get x on top and by itself. So what I'm going to need to do is the opposite of dividing by x is multiplying by x over 1, and then over here I'm going to do the same thing. I'm going to multiply by x. What that does is this will cancel with this, and I get 0.624869 times x is equal to 11. Now, to get rid of this number, I'm just going to divide both sides by 64869. Whatever I do on one side, I got to do on the other side. Okay? Oh, you know what? I wrote this down wrong. It's supposed to be 869. Alright. Okay, so then I'm going to say, clear, 11 divided by 0.624869. And I get x is approximately 17.6. We're going to round to the nearest tenths. Okay? And we could just leave that like that. Does that make sense? So the recap real quick. I'm given this figure. I'm asked to find x. Probably should have wrote that down in the beginning. Asked to find x. I have this right triangle where this measure of this angle is 32 degrees. I identify and label all the sides. The side across from the 90-degree angle is the hypotenuse. The side opposite the 32-degree angle is the opposite side. And the third side is the adjacent because it touches the 32-degree angle. So then I know that the ratio 32 tangent of 32 is a numerical value, but it also has to be proportional or equal to the opposite over the adjacent. So then I say tangent of 32 degrees is equal to the opposite, which is 11, over the adjacent, which is x. Then I have this mathematical equation because I know that the tangent of 32 is equal to 0.6248693, blah, 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 blah. So then I just solve for x like I normally would, and I would get x equals 17.6. Okay? Moving on to example number 3. In example number 3, we're given another triangle like this, and we're told 1 root 3, this is my 90-degree angle, and we're told that this is 60 degrees. So we're asked to verify the special right triangle. Now, if you don't remember, the special right triangle is the 60-30 or 30-60, where the ratios or the side lengths are 1, 2, root 3. We did that a day or two ago, right? So then what we want to do is we want to see if it's right. So the way that I can verify that it's right is I'm going to say the tangent of 60 degrees is equal to the opposite over the adjacent. So what's opposite the 60 degrees? Well, first of all, let's label this. Across from the 90-degree angle, this is always the hypotenuse. It's always across from the 90-degree angle. And then from our 60-degree angle, which is what we're curious about, across from the 60-degree angle is the opposite side. And then the one left over is what we call the adjacent. In other words, tangent of 60 should equal the square root of 3 over 1, or just the square root of 3. I can verify that, by the way, if you're not sure, that should be 1.73. How do I know that? I memorized it. So what I want to do is verify that. So I'm going to plug into my calculator the tangent of 60 degrees. And I get 1.732. Alright? So, in other words, 1.732 1.73 is approximately 1.73. So we verified that. That works out correctly. Okay? And that's basically it. Lastly, for example number 4, and then we're done. We're given a real world scenario. You have a tree, perfectly drawn tree, and it has a height of h, and it cast a shadow of 45 feet. Okay? It cast a shadow of 45 feet. And we notice that this angle from the ground to the tip top of the tree, that is 59 degrees. So what are we asked to find? How tall is the tree? And so in order to do that, we have to find the value of h. So let's identify the parts. This is a 90-degree angle, so this side here is the hypotenuse, right? H is what we would call the opposite because it's opposite the 59-degree angle. And 45 is the adjacent because it touches the 59-degree angle. So this is a tangent problem because tangent is equal to the opposite over the adjacent. In other words, the tangent of 59 degrees is equal to h over the adjacent, which is 45. So I'm going to leave this alone for now because I can plug that in the calculator later. If I want to get h by itself, then I need to do the opposite operation of divide by 45, which means I'm going to multiply by 45, and whatever I do on one side, I got to do on the other. 45 divided by 45 is just 1, so the 45's cancel. H times 1 is h, over 1 times 1 is 1, h over 1 is just h. On this side, I could actually do that all in one swoop. If I say 45, try and get that in the light for you guys, times the tangent of 59 degrees, that'll give me a numerical value. 74.9 if I round up to the nearest tenth. In other words, the height of the tree is about 74.9 feet. I could probably put feet in here somewhere. Okay? So let's recap that real quick. We have a tree. We don't know how tall it is. We know that it casts a shadow of 45 feet. If we go to the tip of the shadow and look up at the tree, that forms a 59-degree angle of elevation. So we notice that this is the opposite and the adjacent. The tangent is the trigonometric ratio that compares the opposite over the adjacent. So then we're going to have an equation, tangent of 59 is equal to h over 45. Do some algebra and we get h is 74.9. In other words, the tree is 74.9 feet tall.